slide rule to the moon. That's the subject of my talk. You might wonder why, because I consider it to be a catalyst of change for engineers, as I will kind of indicate as we go on. So the beginnings, as probably most of you know, or at least I would say the vast majority of you would know, slide rules began because in the 16th century, Napier, of course, invented the concept of the logarithm. And as you know, those that are my age will know that you've used log tables. So hands up, who's actually used log tables? So about half. Okay, fine. So I mean, the age difference is around about 1975 is the cutoff, where you probably didn't use these things, so you actually were allowed to use calculators. So the log tables is very useful for doing multiplications and divisions, because, of course, with logs, you add two numbers to do a multiplication, and you subtract two numbers to do a division. Very handy. It makes the whole process of doing maths in a simpler way. What is a slide rule? This is actually one of my oldest in my collection, which I bought, as Roderick said, 2 weeks ago, probably. Slightly tatty box. However, this is made in 1959. It's a Faber-Castell. It's, I think this one is the Mannheim, so it has just very simple scales, A, B, C, D. Basically, the scales here, of course, are index 1, and you notice here we have 10, and that is obviously 10 squared. So x squared. So that's how you do your squares. The top ruler is just for doing measurements in, as a conventional ruler. So that's an old slide rule. Now, this is just for those that haven't used a slide rule. Okay, who's actually not used a slide rule? Fine. Okay, I'm going to concentrate for those people that haven't used a slide rule. So for those who haven't used a slide rule, if you want to do a multiplication, then you set the index point to the first number you want to, for example, multiply. So here in this very simple example, for an illustration, 2 times x, set the index point to 1 to 2, and then you can see quite easily that as you scan along, you can also do other x's as well. So 2 times here, 2 times 2 is 4, obviously. 2 times 3 is 6. 2 times 5 is 10. And if you've not used one of these particular type of slide rules before, you may wonder, how am I going to do 2 times 6? What you would ordinarily have to do, if you don't have this scale up here, is to move the 10 index pointer to there, and then read the result here. However, this has a folding scale. It's a junior, it has a folding scale, which means that if you read here 2 times 5, the 2 times 6 actually is up here. 2 times 6 is 12. So obviously it's got 1.2, but you need to make a mental note where the decimal point is. So you need to approximate that in your own head. So 2 times 7 obviously would be here, for example, or rather here, 14. So that's basically how you do multiplication. You also have to learn how to do the subdivisions, so you can approximate to approximately 3 significant digits. In some cases, you can go as good as 4. Right, so let me just move the cursor pointer. So this is how you do a division. So the first number you put on this scale here, and the second number up here. So I've already set it up. I've done a very simple approximation, which probably most of you know. This is the best approximation for working out pi, 355 divided by 113, and it's set up accordingly up here. So we've got 355 divided by 113. And the answer, of course, you read at the index point, which, of course, points to pi, because obviously pi is an important number, it's a constant, and it's indicated there. Also, you will notice that on the top scale, you will also see pi as a result up here as well. Or at least, I should say, this index, because this is a folder scale, which means that the actual index point, which is normally at the end, is actually in the center. So because it's in the center, it actually starts from either end being pi. So the center point is actually there, which is why you have these two chevrons, and that indicates precisely the answer there, pi. So that's how you do simple calculations. Obviously, I could give many examples here. Obviously, Albert Einstein, of course, used the same slide rule as Werner von Braun. However, my talk is about slide rule to the moon, so I think this guy is probably more relevant to my talk. This is actually his slide rule, which he used back in the day. This is a Nestle 23R, which is worth to collect, by the way, a Nestle 23R. Very simple. It's actually the same as the one I've got, but in Faber-Castell. It's a Mannheim. Very simple, just has 4 scales. Right, slide rule to the moon. We are getting there. Can this be true? Well, obviously we know it's true. This guy proves it is true. Buzz Aldrin. He actually, all astronauts actually had a small slide rule which they actually took in space with them for doing fuel calculations as a backup to the main computer. Now, this is a very good diagram. It's actually not a diagram. I'll show you later. This is actually a working diagram written in Java. And this actually is the calculator that actually was used by NASA. It was very small, only about 5 or 6 inches, made from solid aluminium, which means, of course, it's not flammable. And this was used in space. And it also had logs, so you could do logs and trigs. So it was quite a complex slide rule. It's also double-sided as well. But this is actually the slide rule that was used in space. Buzz Aldrin actually sold his slide rule privately. Everybody else kept theirs, but he sold his, I think, for $75,000 US, just as a point of interest. Right, a little bit of text here. Okay, slide rules in space. So pocket slide rules made by Pickett. This is the most famous American maker for slide rules. And they were used as a backup aid to the flight computers, used for doing fuel calculations, especially on the LEM. That's the Lunar Excursion Module. And it was actually used for doing a final check on the fuel calculations when Buzz Aldrin was coming in with Neil Armstrong, where they were running a bit low on fuel. He did a check on his slide rule. So, important point. But this is not the complete story. Slide rules were used by rocket scientists or engineers, and it was the standard engineers tool. That I'm sure everybody knows. They have a general accuracy of between 3 and 4 significant digits, which is interesting, especially as we, of course, are all enthusiasts with calculators that are infinitely more accurate than that. However, for mechanical systems, 3 to 4 digits is probably all you really need when you're actually doing experiments where you have lots of variables. So you could therefore say that Apollo 5 was in part designed with the help of a slide rule. The story doesn't stop there. We have computers. Now, back in NASA time, early 1960s, before the actual moon landing in '69, we had computers. These ladies here, who are very famous, they're in the Hall of Fame, Katherine Johnson, Dorothy Vaughan, and Murray Jackson. They were the human computers. They were head of their team. It was a remarkable story. And what they did, they essentially, with a whole team of people that were computers, they actually performed lots of calculations using mechanical tabulating devices because computers just could not keep up. However, at some point before the moon landing, computers did become available from IBM. They were programmed in Fortran. And of course, it goes without saying that these remarkable ladies learned to actually program in Fortran and actually then became programmers as well as computers. So very important story. And mechanical computers, of course, not to be confused with something like a HP35. So back in the day, computers were also people that actually computed. So slide rules developed at great speed through the 50s, 60s, right to the end of their era, actually, which was the mid-'75 when the calculator came out. Just using the Aristo, they used new materials, which they called proprietary name Astrolon. It's a form of PVC. very robust, very stable, and they were used for all sorts of things. Some of the examples you've seen, just very simple slide rule calculations, but way more complicated than that. I've given us two examples here. One which I nearly bought, which was the radiation dose protection. Beautiful slide rule. Unfortunately, they're very, very rare. One I have bought, you'll be pleased to know, is for doing concrete reinforced steel calculations. Beautiful.
You use it all the time.
I use it all the time. I used it to work out my breakfast before I got here. Gamma and X-ray radiography, if you believe that, you believe anything. EKG, electrocardiogram, there's one that Faber-Castell was designed specifically for the ECG measurements, and electro, which I have today. So I have actually an electro here, made by Unique, and a normal one, which is here as well. So the list is endless. I mean, slide rules are nothing more than slides and tables. Some slide rules, I think, it's pity Tony's not here today. Tony did bring, at the last meeting we had, some examples of some paper cards with cut-out slots for doing photometric calculations. And they weren't exactly a slide rule, but it was like a table that you could tabulate. So that was another example. So the key thing here is that these type of dedicated devices are not just slide rules which do specific things like trigs or logs or those type of things, but it also does formula as well. It does complicated formula, which in a sense is the forerunner of the modern day apps which we use today. And also, before we got to apps, of course, we had the Hewlett-Packard calculator. Now here's some examples of some of the exotics out there. This happens to be one I bought last week. So this is the Risto Starbeton, which is a concrete reinforced steel calculator. Notice the slide is extremely complex. Please don't ask me to explain how it works, as I haven't figured that out yet. I do have the instructions for this in German. Vlodek, no doubt, will help me. But even then, I think it will be difficult because mechanical engineering and reinforced steel is not my particular subject. But it has the beautiful, I call them eyelashes, beautiful curves here. It's just an exotic piece of art. The flip side is also very exotic as well. So this is an example of a very dedicated slide rule. And then we have something here which is my other recent acquisition. I know Vlodek's got one of these as well. This is the Studio Log. So this is actually something I'm very proud to have actually, I did actually snag that one. A bit more expensive than I was intending to go, but I got it. So this is the Studio Log, which is larger than an average slide rule, quite heavy. Mine came all the way from Germany, and it got here in one piece, which was amazing. It has the instructions again, of course, in German. The main feature with this, which I will show later, is that it has everything you could possibly want for doing trigonometry, and also it has 8 log-log conversions, which if you're doing financial investments, or if you're doing biology where you're doing growth samples, this is perfect for that. So this is really for all scientists. Here's another flip side of the slide rule. You can see all the logs here, 8 of them. That's extremely comprehensive. You cannot get more than that. And on the trig side, we have T1, T2. Even we have CI and DI as well. And a little note with, if you do start collecting these things, I hope you do, Aristos, they are very good at actually putting the date code here, using the Astroflex code. So 2 means it's made in Hamburg, and LT means it's 1972. So this is actually one of the last slide rules made before, around about, remind me, when did HP35 come out? 72, 73. So this was coming out, being manufactured, just around about the time when the HP35 was hitting market. So this really represents the end of the era of the slide rule, because the HP35 was transformative. But the concrete one went on to 1978 because that was very specific and was used by engineers doing that type of field. The one which many of us might want to get, I certainly do, maybe we should share when we go to bid for these things, is the 0972 Hyperlog. The last one sold for this price, ridiculous. I did not bid for that because that's obviously insane. But obviously this is extremely valuable. It has hyperbolics. Now hyperbolics, as you know, are very useful for doing telecommunications, if that's the sort of things you're doing. So now I'm going to do a slight tangent here. Okay, so all of us, we have the holy trinity of calculators. Maybe we do, maybe we don't. HP 35, 65, 67. You don't stop there. You get the 41C, CV, CX, 42S. I certainly got that, and I got the 27S. Thank you, Andrew, for restoring my 27S, which works amazingly, and the 28C, which I got from America, and the 28S, which I bought from here as well. So these are, for me, the really important calculators. But what does all this equate to? Well, obviously it means you're a collector. So by definition, I am a collector. You decide getting a few slide rules. Perhaps you settle on these names. So I think somebody mentioned British Thornton. Yes, I am collecting British Thornton, and I'm collecting unique here, Faber-Castell, Aristo. And then, okay, you buy the first, the second, and the third, which I think I'm up to about slide rule number 28 or number 30 now. So the excitement and anticipation mounts. We've all been there after all. That's what we're doing for HP calculators. No difference, you're a collector. So I am definitely a collector. Problem is, though, and this applies probably to quite a few of us, I suspect, where do you stop? You look at the cost, you check on the storage space, and this applies to me in my house. You look for growing collections. Perhaps you need a new house. Perhaps you need an outhouse. You are a museum. So we are a museum. So many of us, anybody who has more than 10 or 20 or 30 slide rules or calculators is a museum. So we are a museum. This is some examples of my collection I've done in my past 2 weeks or whatever. British Thorntons to make people that were British Thorntons. You happy? Okay.
Yes.
And these are not your average ones. These are brand new, with a manual, with a box, and I've got 2 comprehensives. So I've got 2 comprehensives and an AD 150 advanced. I worked really hard to get those. These are some of the unusual ones. Electro. Electro basically is a normal slide rule, but it has a scale which is 2 times pi. For those of you who do electronics, you instantly know why 2 times pi is important. And it also has some other scales as well for doing power conversions. These obviously quite old Faber-Castells. Disponent basically is a business slide rule. It's actually, disponent means manager. I have 3 of those. Not because I want to be a manager, but because they're very interesting. They actually have pounds, shillings, and pence conversion, and you can do bank interest calculation. Effectively, this is equivalent to, you could say it's equivalent to a HP 12C. You would do the same type of calculations on the disponent. These are pocket calculators. This one is very unusual. If Tony was here, he'd be very interested to see that. This one here is actually made by AEG. For AEG Telefunken is actually made by Aristo. So it has a unique manufacturing code, and it's made for AEG Telefunken. And it has 2 very unusual scales, which I can probably zoom in, or maybe not zoom in. I leave it as it is. But if you could zoom in, you've got 2 scales which are specific to power energy conversion. Basically, it has the cosinus psi. And what else do we have? This one is upside down. This is an Aristo Electro, which is of interest to those who do electronics. Unique slide rules, of course, very beautiful. These ones I bought, believe it or not, brand new. They were sold brand new. How can you have something brand new from they were made in 1972 in wood, but it is brand new. I had to actually break the plastic that was actually inside. Absolutely remarkable. There was a piece of protective foam completely gone to powder. So obviously that justified that they were obviously very old. These I haven't sorted yet, but in there somewhere there's the hyperlog. And this is from America, so I thought better be kind to our American colleagues. So for those watching in America, this is a picket. And not only is this a picket, but this is a brand new picket. That's the original plastic bag. And this picket is designed for electrical calculations. So that's a very rare, very unusual picket. Okay, wrapping up. Okay, so you buy a bundle, which I did, and I got this unusual thing, which I believe Vlodek got one as well. And when I got this, it kind of blew my mind because I couldn't work it out. because if you know slide rules, A, B, C, D, this actually has A, B, C, D going in the reverse direction. So the scales are the same scales where you've got the X at bottom, so 1 to 10, and the top scale, which is square, so X squared. So, but yet they've reversed the letter code. Why would you do that? So this is a very unusual calculator. On the back of the calculator, for me they are calculators, it actually has this, which is a school in Germany near the border of Switzerland where they actually did slide rule class. And they, for some obscure reason, which we don't know, they actually reversed the letter codes for these. So basically, it's time to retire because obviously, having got something so ridiculous, what else can you do? Probably you want to see the demo at this point. So obviously, this is a discussion. I'm hoping to do something a little bit risque. When I did this talk 2023 about emulators, as you know, I'm a big fan of emulators, even though I've started to build up a collection of calculators now, real calculators. I do like emulators. It kind of figures that I've gone into that also with slide rules. So I don't know if this is going to work. It might work. If it does work, great. If it doesn't work, forgive me. I think I actually probably need to end this presentation. There you go. Right. Now, I don't know if we should call this emulators. This is all written in Java code, but we can actually do things like this. And we can actually do real calculations. So the calculation I showed you, this is a list of hyperlog, because this is obviously my slide rule that I would like to purchase. So I have got it. I have got it, but I don't own it, a real thing. So if I move this to here, we can also do crazy things. Now this ties in exactly to us as having calculators, because I can do things that slide rules were never meant to do. I can be really naughty. I can do particularly naughty things. So, and I can get rather high accuracy on this, because inside the kernel of the code is actually real calculations taking place. So I can actually, you'll see the numbers change. So I can actually get this lined up as close as I can to 3.0. However, that's not good enough for me. I might want to actually enter precisely 3.000. So this is like the world's most amazing thing. And that takes the cursor directly to 3.00000. Having done that, then I can so basically you can do real calculation, but let's do it very quickly. So if I move the cursor to number 3, turn that marking off because we're trying to emulate a real slide rule here. Enter, let's say, 2.54, like so, and then get the answer here. What I've done, I've taken 300 millimeters, divided by the conversion factor for millimeters to inches, which is 2.54, and the answer should be here. So the answer, I will read it. I know what the answer is, but I can read it as 1. So the way you read this is 1, where it comes down here. So basically, you've got 3 here, and then you've got, actually, it would help if I actually got this lined up correctly.
You know where to move to read the answer.
Yeah, no, yeah, exactly. No, it's my own fault. Actually, it would probably help if I get it in the right place. So 2.54 is actually about there. All right, and then get that into the correct place. Okay, so 2.54 over 3, which should be, 2.5. And the answer is 1.181, which is actually the correct answer. We can see that's the case because we can actually read the markings on using this emulator, which is pretty close. So 1.18. It actually gives 3.8 as well. So now this is one surface of the slide rule. I told you that slide rules, these complex ones, have 2 sides. And you will notice the readings that are on the cursor will be maintained. So when you do a 3-dimensional flip, which I will do now, so I'm now going to go to the back of the slide rule. We can also see both surfaces as well, if we wish. So it's flipped. So now the readings are actually passed through from both surfaces. But here we have the hyperbolics. This is what everybody wants this because this has hyperbolics, H2, SH1, H1, and SH2. Would we use them? If you do telecommunications, you might. But obviously, this is definitely the slide rule to have. However, I'm not satisfied with one slide rule. So what I'm going to do is actually select any slide rule. So the one that both Floddy and myself have bought recently, no, I would do Andrew, because Andrew has bought a very beautiful slide rule. I believe he had very tough competition, but he snagged it. We were both bidding for the same slide rule, and Andrew beat me. Congratulations, Andrew. And Andrew bought this. I'm going to show you now. Actually, we now have a refresh crash. So let me correct this mistake. Yes, I had a funny feeling this might happen. Sorry about this. Right. Okay. I had a funny feeling that this might actually happen. It's because I'm using a virtual HT server. Right, okay, so let's go to here. This might hopefully work. Amazing. Right, okay. This is your slide rule. I say your slide rule because this is your slide rule. Could be mine if I gone a bit higher, but anyway, there you go. So we can see both sides of the slide rule. So using emulation like this, we can actually preserve slide rules. So to chime in with the emulation talk I gave, I suspect when all our HP calculators eventually bite the dust, which hopefully won't be for a very long time, but eventually plastics and things will degrade. When we as a club visited the Whipple Museum, there was Flodek, there was Mark and Bruce. We met the curator, and what the curator said to us was very interesting. They said that they keep things in a dark condition, they take the batteries out, but the one thing they cannot do is prevent the plastics, which the calculators, HPs, are made from decomposing. That over time they will eventually go to dust. And I rather suspect, even with slide rules, that's sadly the case. But the one good thing with slide rules is that they're made from something called a very hardened form of PVC, and they have a lifespan of between 100 and 200 years. Whereas I believe the HP calculators that we have, do we have any HPs today? We do? Okay. Well, the classics that we have, like the HP 35, 45, and so forth, they are made from polycarbonate plastic. And polycarbonate has a lifespan of about 60 years. So we hope they will last. But these things might last longer, actually, than the calculators.
I suspect being left in sunlight changes them.
Oh, totally. If you leave any slide rule, they will distort and the colors will change. The same is true with the HP calculators. But the polycarbonates are much more resilient to drops and bangs, whereas these things are more resilient to contraction and expansion, which you don't want. Anyway, so that's kind of I suppose let's end on a happy note then. For young kids, we can do stupid things. This is a Hogwarts slide rule, and it plays you suitable music. So on that note, I end my talk. And any questions? Questions? Let me come out of this.
Nigel, in the early 30s, Nigel Shute was designing the R100 airship for Vickers, or with a team. The R100 was a successful one, actually. It went to Montreal and came back. R101 is the one that crashed in France with diesel engines. But the successful one was being stressed, a very, very difficult job. And to do it, he used a rotary slide rule, a British one, actually. And it was equivalent, it was about this size, but it's equivalent to about a 5-foot slide rule.
Oh, wow.
So that's for your next collection.
That's probably for my next collection. I mean, Well, I mean, feel free to have a look at these. I mean, I suppose I should say, this is not actually the one that I bought when I was a schoolboy, going to study maths at school. But this is the same model as I bought. The one I bought, I've still got it at home somewhere. It's in storage. So what I've done, I've actually bought this one. It's a unique universal one. So this actually, not this actual physical one, but this model is actually the one it was the very first slide rule I bought with my pocket money. And it's a very nice thing. It's made from wood, works very well. It's simple. It has simple functions. This one here is rather unusual. For those of you who do electronics, this is a electro. So this is a unique slide rule, and it has temperature conversion here, which is important if you are measuring the performance loss of cables, power losses, and temperature coefficients and things like that. And on the back you have all the sort of things that all good electronics or electrical engineers would want. So that's an electro, and this one is what I used. I mean, I can say that because this is the same model. This is one I used for when I was doing my O levels, O-level maths. And then from O-level maths, when I went to do A levels, I did physics and what did I do? I did applied maths and pure maths, and that's when I got my first German Aristo, which of course naturally was the studio. Which actually I can show you what that looks like, because I think some of us actually has those.
What does the wood do for you, Nigel? And having the wood instead of pure plastic like the Thornton?
I think what I like about the wood, and especially with the Faber-Castell wood, is that when I touch a wooden slide rule, it's very, obviously, if I say it's very organic, it's obviously very organic, because it's obviously wood is organic, but it just feels really nice. It also slides really smooth, whereas some of the plastic slide rules can be a bit stick. Aristo actually are made from a very soft PVC plastic. Did I say PVC? PVC plastic, and they actually seem to go quite well. So this one you see up here is a standard studio. I think Launch is beckoning. A standard studio, and this is the flip side of the studio. So many of us, I think, would have studios. Perhaps this is what I use for doing A level. So we have all the trig functions. We have T1 and T2, which is always good to have that because it means you get finer resolution with tangents. And then you get, most importantly, as I showed you earlier, you have the DF and the CS scale, which actually is the same as the C and D scale. The reason it has F, for those who don't know it, F stands for folding. And that's the folding scale that is folded at pi. So you have the one position here, which is the index point. So that's why you can do a calculation here and then continue that up here. Unlike the other ones I've showed you, which has x and then x squared above, that's not the case. That's why they've got the same letters, C and CF, because it's the same x, it's not squared. So for squared, you would use another scale. Oh, you also have P for Pythagoras, so you can do Pythagoras calculations. Most important, if you're doing science, as I was, you have all the logs. So you have 6 logs if you're doing exponential stuff like that. So this was the one I used. I was very honoured that my mother bought me this one. I had to ask my mother, and she actually went to buy that. These are not cheap, even back in the day. So that was the first one I had. So what's your first slide rule?
Thornton.
Excellent.
We were told at Leeds to go by Thornton, so it was that simple.
All right. Which one did you have?
This was in the 60s. I still have it. I'm not sure which model.
This is the one I bought recently. So this is the British Thornton Comprehensive, and this is both sides.
It didn't have the yellow on the sides, it was grey.
Yeah, sure. Artistic license, I suppose. So British Thornton, very nice. I mean, the thing with the British Thorntons is that, again, this is kind of equivalent to the Aristo Studio, but this is British. It has S, STT, it has all the trig functions. It has something very unusual, which is very unique to British Thorntons, totally unique, in fact. if you notice on the various scales, you've got the 6 log scales, which is great. So that's equivalent to the Risto Studio. But it has something very unusual. If you look here, it has ISD and TD. Those are differential trigs. And they're designed to be very precise in small numbers.
I'm not sure it's the same thing, but on mine, it had a separate from 0 to 6 degrees. You could get sines and cos over the whole width, and it gave great accuracy, actually.
Really?
It beat the Sinclair when I compared the two. Sinclair was
Wow.
famous for low angles.
Can you bring that in next time?
Sorry?
Can you bring that in next time?
Yes, yeah. Well,
be interested to see that. Okay,
well,
well,
that might be a unique feature, that blowing up the small angles.
I probably best stop talking because I think everybody wants to go for lunch. But any more questions about slide rules?
I think the Whipple had a rotary, by the way.
Which one?
I think the Whipple had a rotary.
Oh, the Whipple Museum in Cambridge. We must go back there actually and maybe have a look at slide rules as well. Anyway, that's it.